Hi, seventh graders. Today we're going to consolidate what we have learned about integers and absolute value. So when we talk about absolute value, remember that's the distance a number is from zero. And so what we have here, we actually have mistakes over here that we are going to find the mistakes. We're going to solve them and kind of explain them over here. And we'll do some more down here below as well. So this first statement says absolute value is the distance a number is from zero. It will always be the opposite of the integer. So if we think about when absolute value is the distance a number is from zero, it's not always the opposite. It's actually just always going to be positive. So some examples to show that would be like the absolute value of -6 is 6, and the absolute value of +6 is also 6. So it's just how far those numbers are from zero. On this next example, it says the absolute value of 3 is equal to -3. So if we stop and decide if that's what the mistake is there, the absolute value of 3 is actually +3, because again, it's the distance it is from zero. This next one's a little tricky. So we have the absolute value of -8, but then we have this extra negative sign, or another way to read that is opposite of. So this is like the opposite of the absolute value of -8. So the absolute value of -8 is 8, and then the opposite of that would be -8. So this would actually, because that extra negative sign is on the outside of those brackets, this becomes -8. And then on this last one, -4 is less than -9. So when we compare -4 and -9, if we think of a number line, -4 is farther to the right. Your greater numbers are going to be further to the right. So -4 is greater than -9. On this next set, find the mistakes. So it says a number and its opposite actually there's only one mistake in this box. All right, so a number and its opposite are on different sides of zero and have the same absolute value. So if we think about if that's true or not, that is true. All right, so a number and its opposite, they're on different sides of zero, they have the same absolute value. So for example, -3 and +3 are opposites. They have the same absolute value. The second statement, a number and its additive inverse will have a sum of 0 or form a zero pair. So we haven't talked a whole lot about additive inverses. We'll talk more about that later in the next few days. But additive inverse, and that's just a fancy way of saying opposite. And so this is saying a number and its opposite will have a sum of 0 or form a zero pair. So we'll talk more about zero pairs when we get to adding, but that's also true. And so this last statement, the values are ordered from least to greatest. So when we look at this and the way that these numbers have been ordered, these are actually not ordered from least to greatest. So the very first thing we would want to do, since we have some absolute value to evaluate here, would be evaluate the absolute value and simplify each of these numbers. So the absolute value of -43 is 43. The absolute value of 25 is 25. Absolute value of -16 is 16. Then we have -16 and 10. So to order these from least to greatest, I want to think of the number furthest on the left to the number furthest on the right. So furthest on the left would be our -16. Then if I look at the rest of these values, then it would come +10. Then it would be this +16. Now I'm going to go ahead and write how it was originally written, which was the absolute value of -16. Then would come 25, but again, I'm going to write it the same way that it originally was, so the absolute value of 25. And then last but not least would be this 43, which was the absolute value of -43. So this would be the correct way to write that in order from least to greatest. So we're going to go ahead and look at some of these. This would be a good time to pause the video, try some, of these problems on your own, and then you can play the video to check your answers. On this first one, it says complete each comparison with less than, greater than, or equal to. So number 1, -5, and then the absolute value of -5. Anytime you see absolute value, you want to simplify that first. So I'm comparing -5 with 5, and -5 is going to be less than 5. So -5 is less than the absolute value of -5. On this next one, I have the absolute value of -4. Well, I know that's 4. So I'm comparing 4 and 1. So the absolute value of -4 would be greater than 1. And then here I just have 2 negatives. There's no absolute value. So this is going to be where I want to make sure that I'm kind of visualizing a number line and where each of those numbers would be located. And so -17 is farther on the left. So -17 is less than -6. On number 3, this is kind of where I have that negative or opposite of outside of the brackets. So I need the opposite of the absolute value of -15. So I'm going to simplify what's inside of the brackets first. So that's just 15, and then the opposite of that would be -15. On number 4, these brackets again are like grouping symbols, so we actually solve whatever is inside of them first in our order of operations. So we would do 14 minus 3 is 11, and then I'm going to take the absolute value of 11, which is 11. Number 5, we are going to order these from least to greatest. Again, if you have any absolute value, you want to simplify whatever that value would be. So the absolute value of 15 is 15. The absolute value of -8 is 8. So my numbers that I need to compare and order are down here, and so I'm going to start with the one that would be farthest on the left, which would be -10. Then would come -7. Now I'm done with my negatives, so I'm going to start going positive. +8 would come next, but I'm going to write it the way it originally was. So the absolute value of -8. Then would come 12, and then the positive 15, which was the absolute value of 15. If there's anything else you want to remember about integers, their opposites, or absolute value, go ahead and add that below. Have a wonderful day.